Question 3. Define binding energy per nucleon. So binding energy per nucleon is the binding energy. okay, it's okay. Binding energy per nucleon is the binding energy per nucleon number. Itu je lah, per nucleon number. And then question B, number 1. So we have I think, what is that? Is that phosphorus? PO? I'm not sure. I think it's phosphorus. Potassium. Let me double check. PO. PO. What is this isotope? Polonium. Seriously? It's polonium? What is that? Okay, it's polonium, everybody. It's not potassium or phosphorus. Yummy. So weird. Okay, never mind. Yes. Okay, so PO is polonium. So this is 21884. It has a mass of the mass of the nucleus is 218.0090 U. If the mass of the proton are 1.0073 U and mass of the neutron is 1.0087 U, calculate the binding energy per nucleon of the nucleus. Okay, so for this one, we are gonna look for EB over A. E, binding energy over the nucleon number. Okay, so from here, this is our A, this is our Z. So here we are gonna firstly calculate the binding energy lah. So we are looking for this. So we need the binding energy, which is delta M C square. But before we can calculate the binding energy, we need to calculate the mass defect, which is ZMP plus N Mn minus mass of the nucleus. So put the bracket here, multiply it with C square. So you will then get the binding energy to be equal to 1648.755 mega electron volt. Okay, so this one we can then calculate the binding energy per nucleon number. We divide it with 218. Okay, so we divide it with 218, we get 7.56 mega electron volt per nucleon. Okay, jangan lupa, we are calculating it in mega electron volt. Mega electron volt. So when you are dividing it with the nucleon number, remember to include mega electron volt, not just electron volt. Okay, question 2 pula. The binding energy per nucleon of oxygen is 7.98 mega electron volt per nucleon. So this is given as the binding energy per nucleon. So what is the mass of the nucleus in atomic mass unit, which is U? Okay, so the binding energy per nucleon for oxygen is given, and for 16... Astaga. Did you hear that? My cat just jumped off from the fan, bro. Okay, it's okay. So now we are gonna calculate the binding energy per nucleon for 16 nucleon number. So we multiply it. We need, okay, good job. Let me just reset. So the binding energy per nucleon is given as 7.98 mega electron volt per nucleon, right? So we need only the binding energy. So we multiply it with 16, which is the nucleon number. Okay, the nucleon number is 16. So from here, you will get 127.68 mega electron volt. Okay, so I'm doing this in mega electron volt. So after getting the binding energy, we can then use the binding energy punya equation to find the mass defect. Why do we need the mass defect? It's because we are looking for the mass of the nucleus. Okay, so this is gonna be equal to 0.13707 atomic mass unit. Okay, I've directly convert the value into U sudah. If you have any problem on this and at this part, please let me know in Telegram. After that, we are gonna use the mass defect punya equation, that is this mass of the oxygen nucleus. So from here, you will then get the mass of oxygen nucleus, rearrange it, and then you will get 16 16U. 16U lah, okay? Itulah jawapan dia. Betul lah. Boleh faham ah? I'm sorry if it's a bit confusing. But basically what you need to do is you need to first find the binding energy because you need the delta M. Okay, so we can't use directly this one because this is per nucleon number. So after that, after calculating the delta M, you can then use this equation to find the mass of the nucleus. But make sure you use U terus lah, atomic mass unit. You just have to multiply this with this one. You have to multiply delta M ni, you have to multiply it with the value of C yang 931 something. This one, 931 mega electron volt. This one. Okay? Alright, that is on question number 3.